Hey guys, what's up? Kelvin here. Today we're going to be starting our CCNP level overview of route summarization. So if you recall in our last video, we covered the CCNA level overview of route summarization. So that is to say we covered what is route summarization in the first place, why you would want to use it, and how you do the supernetting that's required to create the summary subnet. If you haven't seen that video, the link is in the description below. I would highly recommend you look at that video if you need to understand what route summarization is, because I will go on with these videos assuming that you already understand that concept. So again, if you need to pick it up or have any questions, just go ahead and look in that video down there. I'm sure any questions in there will be answered, and if not, you can go ahead and post a comment in the comment section of that video. I'm sure I'll get to it. But anyway, going on with this video, today we're going to be beginning the first routing protocol out of the three that I'm going to cover for the CCNP level overview. So there's OSPF, which is this video, BGP, and EIGRP. Before I begin off with the rest of this video, I should warn you that there is a fair amount of assumed knowledge in this video. Firstly, I'm assuming that you already understand the fundamentals of route summarization. Besides, if you don't understand route summarization as a fundamental concept, you're not going to be able to understand how to implement it. So, if you don't understand the fundamentals of route summarization yet, as I mentioned in the intro of this video, there is a link to the CCNA level route summarization that I did down in the description below. The second thing that you're going to need is a fundamental working knowledge of OSPF, so probably something like a CCNA level overview of OSPF, since this is a CCNP level video. Just some understanding of basic rules and structure of OSPF. With that out of the way, let's begin. So, OSPF is a protocol that I picked for the first video because it has some interesting rules as it relates to summarization. Firstly, the non-backbone areas have to hook into the backbone, right? So I've got area 1, area 2, area 51, who cares, right? Have to hook into area 0 in some way, shape, or form. The other rule, which I personally think is more important as it relates to summarization, is the fact that within an area, right, all routers are in an area have to share the same area LSDB, the link state database. Well, what do I mean by this? This is going to be a review for some of you, but I just wanted to cover it anyway just to cover all my bases. So, assuming that you have, let's say that R1's advertising, if you refer to this diagram over here, let's say that R1 in this case is advertising 5 prefixes, right? Let's start small. 5 prefixes. And R1's advertising it to R2. Now, let's say that R1 and R2 are both in area 0, right? Just make it simple. So when R1 advertises those 5 prefixes, R1 is going to create a type 1 LSA for each of those prefixes, and it's going to stick it into its area 0 link state database, because there's a link state database for every single area. Now, when those LSAs get advertised in link state update packets to R2, R2 is going to receive those and put it into its link state database. But what's important is that R1 and R2, at the CCNP level at least, have a one-for-one replicate of each other's LSDBs, right? They have to have the exact same LSDB down to the checksum. Now, here's the problem with that, right? If you're doing summarization, you're inherently lying. Let's say that R1 and R2 and R3 on this diagram are all in the same area, right? Let's say that they're all in area 0, right? This is not the final diagram. This is just for demonstration, right? So R1, R2, R3 are all in area 0. I should probably put A0 for some clarity. Sorry for my drawing skills. I'm trying to draw on the mouse, and you guys know how that is. Anyway, now, if R1, say, advertises 5,000 prefixes instead of just 5 this time, and R2 says, I want to be a nice neighbor, so I'm going to kind of quiet down about those 5,000 prefixes and just kind of summarize it for you, R3. I'm going to send you a summary, right? Well, now you're lying to R3 as R2, because R2 is basically telling R3, hey, R1 sent me 1 prefix up there, even though in reality R1 actually sent 5,000 prefixes, and R2 is just not caring to tell R3 about those 5,000 individual prefixes, but R2 just cares about telling R3 about the summary of all 5,000 prefixes that R1 sent. By doing that, you're lying to him, because R2 has those 5,000 prefixes in his area 0 database because R1 sent them. So R1 and R2 are Gucci Gucci. But router 3, when router 2 sends that link state update down with that summary prefix, he's going to put it into his link state database, and this link state database is not going to be consistent with R2, which poses a problem for our OSPF rules, because in OSPF, your link state databases have to be the same for the routers in an area. Right? R3 has to know about those 5,000 prefixes, but then that kind of makes route summarization pointless, because if R3 has to know about those 5,000 prefixes anyway, well, you can't really summarize there. He's going to know about them. So that places us in a dilemma with intra-area summarization, because we can't get past the fact that our LSDBs have to be the same, at least at the CCNP level. Now, the way we get around this, let's say that we're not doing intra-area summarization. Let's say that we decide to build this network using multi-area OSPF, and we make this link, and green means area, by the way, just for future reference. Let's say that we make this link part of area 0, and we make this link, oops, let me finish on high 0, and we make this link part of area 1. Well, now we can do summarization without breaking the rules of OSPF, because if R1 advertises 5,000 prefixes down to R2, right? Well, R2 has them in its area 0 LSDB, has all 5,000, so we're good there, right? But then when R2 goes to summarize to R3, we're not dealing with the area 0 LSDB anymore. Router 3 knows nothing about area 0's LSDB. He just knows that he has one link state database, and that's for area 1. R2 has that same link state database because this interface leading to area 3, or router 3, I'm sorry, is in area 1. So he has both an area 0 and an area 1 link state database. So what is he going to do? Well, without route summarization, just default behavior, router 2 takes those 5,000 prefixes that he just learned from R1 and he has in his area 0 LSDB, and he's going to convert them to type 3 LSAs and put them into area 1. And this is where the power of summarization comes in with LSPF, because we have much more control over what router 2 decides to put into those type 3 LSAs than how he decides to forward type 1 LSAs coming from R1. When router 2 goes in to take those type 1 LSAs from area 0 and convert them to type 3 LSAs to be injected into area 1, that's where our power of summarization. So in summary, that's how we're going to be doing route summarization in OSPF. It's using inter-area summarization because we want our LSDBs to be consistent in an area. So if we have, this is actually going to be a final diagram that we're using, right? We have router 1, router 2, router 3, and router 2 is our area border router because for area 1, because it's connected to area 0 and it's connected to a non-backbone area that fulfills the requirements of being an ABR. Now, how we're going to actually do this is I have a lab set up in Cisco Modeling Labs, which I'm going to have actually a few videos coming on later about deploying and automating the heck out of it. Stay tuned for those videos if you're excited, and leave a comment below if you want to see them. So this is the Cisco Modeling Labs diagram of topology that we're going to be using in this demonstration. So as you can see, this looks kind of different from that one node. Let me bring it back up. This looks kind of different from that one node, and that's because I've got sub-interfaces configured. This is how I typically configure my labs. I have 3 routers, in this case, connected to an unmanaged switch, and then we bring my configuration over here and do a show IP interface brief. You can see that, well, 1, 2, in this case, I number my sub-interfaces for the routers that they're connecting between. So 1, 2 means router 1 to router 2, 2, 3 means router 2 to 3, as you can see here. So it will match up with this diagram, even if the physical topology doesn't look that way. Anyway, I just wanted to cover that. So let's bring our configuration in here, because that's what's actually important. I've taken the liberty of creating 7 loopbacks here, starting with 50.0.0.0 and ending with 50.0.0.7, which means that we're going to be summarizing into, ideally, right, our smallest possible summary that includes all those IP addresses is going to be 50.0.0.0/29. because at /29, if you do 2 to 3, which is 8, this is basic subnetting, well, you have 8 addresses that ranges from 0 to 7, which is perfect. And as you can see here with our show interface loopback 0 output, this is going to be a /32. All of these are /32s, actually. And if you look at the router OSPF configuration, I mean, there's not much down here because I put all the, I just realized I put all the IP OSPF commands as interface commands instead of network statements in the OSPF router process. So these are going, you can see here, I've got all of these in area 0, right? And I've got my main interface going to router 2 in area 0, right? Router 2 is our ABR. Now, if I do a show IP route on router 2, this is without any route summarization, by the way, you can see that we have all of our OSPF routes right here, right? We've got 50.0.0.0 to 7. And if we do our show run here, you can see that I would pipe the output, but I'm too lazy. You can see that we've got gig00.12, which is going back to R1 in area 0, and then we've got 23, which goes to R3 in area 1, and the same is true on R3. Now the interesting thing is that if we look on the routing table for router 3, we can see that because we're not doing any summarization, router 2 is just packaging all the type 1 LSAs that I can find into type 3 LSAs, right? Because we don't have any kind of control over what goes into type 3 LSAs and what doesn't yet. So R2's default behavior will be just to take all of the prefixes that I can find, the type 1 LSAs, package them into type 3 LSAs, and spread them out like pollen. So anyway, now we've got this basic infrastructure setup where we've got router 1 advertising 8 prefixes over to R2 in the form of a type 1 LSA, which I can see if I do a show IP OSPF database, right? We can see this one type 1 LSA here in area 0. If I do a show IP OSPF database router, we can see in more detail. We can see that we do indeed have stub networks for all of our loopback interfaces, so 50.0.0.7, and going down in our area 0 router link state, so type 1 LSAs, because those are router LSAs. And if we do our show IP OSPF database again, and we go all the way to the bottom, we can see that in area 1, we have all these summary link states. So what router 2 is doing is it's taking the type 1 LSA here, right, and it's taking the networks inside that type 1 LSA, it's packaging them all into their individual type 3 LSAs and injecting them into the area 1 LSDB to be received by router 3. So let's go ahead and try to control this behavior a little bit. And we start by doing it on router 2. So we can go into our configuration mode, router OSPF1, our OSPF process. So after we go into our OSPF process configuration, the next thing we want to do is enter the area, and then question mark, we obviously have to enter our area, right? So this is going to be the area ID that our routes are coming in from, right? So on router 2, our routes are coming in from router 1. So we're going to say area 0, right? Because router 1 and router 2 are in area 0 together. So those routes are going, the original prefixes are all going to be in the area 0 LSDB, right? If I do a question mark, we've got a bunch of configuration stuff here, right? So we have authentication and capabilities and default costs and stuff. What we're looking for is range, because if you see the description here, it says summarize routes matching address/mask border routers only. So again, this is gonna be something with inter-area summarization where we can only summarize from the area border router, right? So we have range, and then the IP address to match. So in this case, it'd be 50.0.0.0. And then the mask after that, so 255.255.255.248, because that's a /29 mask. If I hit enter, hit end, right, ignore this little error that's just saying that there's a conflicting LSA ID. It should still work. If I go to R3 and I say show IP route OSPF, we can see that it went from list, right, so we have 50.0.0.0 all the way down to 7, to list 1 OIA mask, or this 1 OIA summary route, right, 50.0.0.0/29. We can see that, I mean, this is a fairly small scale example. You could scale this up super easily to reducing route counts by hundreds or even thousands. But if you had even 8 OSPF routes, right, we use one command and condense them all into one type 3 LSA. So now if I go to router 2 and I do the show IP OSPF database, router this time, right? Doesn't change the fact that we have type 1 LSAs, because we can't do that, right? Router 1 knows about those 8 prefixes, so router 2 does as well. But what does change if I go down to show IP OSPF database and I go down to summary link states of area 1 is that now instead of having the 7 or 8 link states down here for type 3 LSAs in area 1, let me get this over here. Now we have one type 3 LSA for the summary prefix. And that shows over here, right? Because we have 50.0.0.0/29, and if I do show IP OSPF database, we can see that that matches up over here. We have a consistent LSDB between router 1 and router 2 because they're in area 0, and a consistent LSDB between router 2 and router 3 because they're in area. So you can see that with the summary route, if I were to ping, let's pick a random one. Let's say that we ping 50.0.0.0/4. We can see that the ping goes through, ping 50.0.0.3. Ping goes through. It uses this route because it's a summary route, right? And it's the longest match in our routing table. If I do the whole routing table, we don't have another longer route for 50.0.0.3. This is the longest route available. So we go 50.0.0.0, and then this goes over to router 2, and then router 2 goes over, uses its routes. It has a more specific route, so let's say we're pinging 50.0.0.3. R3 uses its summary route to get to R2. R2 uses its specific route coming from router 1 to go to router 1, and from there, that's where the loopback is. It is also important to note that we didn't have to use a /29. We could have used another mask if we wanted to. And I'm going to go ahead and redo the area range command just to go ahead and show that. So let's go back to our OSPF process config here. I'm going to go ahead and do a no area 0 range 50.0.0.255.255.255.248. And we're going to do area 1 range, area 0 range 50.0.0.255.255.255. Let's go ahead and say, why not, 224. Same thing here, don't ignore the error. If I go back here to do a show IP route OSPF, show IP route OSPF, not router, oops, we can see that we now have a 50.0.0.0/27. Now the problem is that with longest match routing, right, this is including networks that router 1 doesn't actually own, that router 2 doesn't actually own, rather, right? So router 2 has all the specific routes that it needs, right, because it's not getting a summary from R1, it just has 50.0.0.0/32 and all this, right? And we're going to get to this later. This is actually going to be another video why this no zero route exists. The main problem, however, is that if we have the /27, right, well, let's think about our range of a /27. Well, 2 to the 5 is 32, so the range would be, because the block size is 32, the range would be 0 to 31. Well, let's say that R3 has a route for, let's say that R3 needs to ping 50.0.0.10, right? 50.0.0.10. Well, it's going to be able to hit this route, right? Because it's a /27. 50.0.0.10 is included in 50.0.0.0/27. So it will use this route to get to R2, but when it gets to R2, well, it won't have a route, actually. Except for this route right here, which tells it, hey, route to null 0, aka send it to the garbage can, we don't want it, we're going to drop it, right? Again, I'm going to have a future video on this. It's actually going to be the last video of the route summarization series covering why this null 0 route exists and how it works to prevent routing loops. That's what it's for. But if we didn't have this null 0 route, right, it would just not work, right? Because here's the problem. We don't have a route for 50.0.0.10, right? Ignoring this summary route, or ignoring this no zero route, rather, we don't have a 50.0.0.10 route, so it gets dropped, actually, and there's an ICMP message that's sent back basically saying, hey, I don't have a route for that prefix. So that's why we don't want to be using too large of masks when we're doing our summary. We want to create a small, our summaries need to be as small as possible to include as little networks that we don't actually own or have routes for as possible. So that wraps up our inter-area summarization portion of this video. Oh, but you thought it was over. Oh, no, because while we can't do intra-area summarization, and inter-area summarization, inter not intra, was the only type that I introduced you to at the beginning of this video, it's actually not the only type you can do in LSPF. There's another one you can do, and you might be expected to know it for the CCNP. If we do a question mark in the LSPF process configuration mode, area range is actually not the most obvious command. This is actually a fairly common mistake. Summary address, configure IP address summaries. So this is a fairly common mistake. Some people will think, hey, that says summary address, right? Well, let's just go in, let's just start doing summary address, right? And they find out it doesn't work, that they have to do the area range command for inter-area route summarization. And that's because summary address is used for ASBR route summarization. Because, again, our rule is that the LSDB in an area cannot, or has to be the same between all the routers in an area. So again, going back to our area 0 example, router 1 and router 2 have to have the exact same area 0 link state database down to the checksum. Same thing with router 2 and router 3 with their area 1 link state database has to be the same down to the checksum, down to the finest detail, right? That's why we had to loop around and do inter-area summarization. We had to control what router 2 put into type 3 LSAs when it extracted the critical information from the type 1 LSAs in area 0 and decided to put them into area 1 summary link states, type 3 LSAs. We can do a similar thing with type 5 LSAs. And the difference here is that with router 1, right, we had to summarize at the ABR, right? Router 1 could not be the one summarizing it because it's not the ABR, right? It doesn't have a connection to area 1. So that means that if we wanted to summarize from R1 to R2, we'd have no choice, right? We couldn't with inter-area summarization. But what if instead of just advertising those routes as intra-area routes, right? So in this case, because we have the IP OSPF1 area 0 command, if I do a show IP OSPF interface brief, you can see that our interfaces are all in OSPF. If I do a show IP route here, we can see that we have all of these as intra-TRA area routes here, right? But what if instead of putting them in as intra-area routes, instead of making those interfaces OSPF-enabled interfaces, how about we just redistribute those networks? How about we create OSPF type 5 LSAs? Well, now we have a bit more control. Now, because we're not really lying in a sense, router 1 will never create a type 1 LSA, right? If we redistribute these networks, router 1 will never create a type 1 LSA. They'll only create a type 5 LSA. And we have that same level of control that we do in a type 5 LSA with a type 3 LSA. Now you might be wondering, right? And reasonably so, I'm going to bring up my OneNote here because I want to diagram this. If we couldn't do that with type 1 LSAs, why can we do that with type 5 LSAs? Why is it not breaking the rules of LSPF if we summarize a type 5 LSA but not a type 1 LSA? And it's because the type 1 LSA, when any OSPF interface becomes enabled, right, it becomes a the network that's associated with an interface becomes a type 1 LSA. So the second I do network, blah, 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 and an interface gets matched by that. The second I do an IP OSPF process ID area number command under the interface, a type 1 LSA is, bam, generated like that for the network that is associated with an interface, whereas redistribution with a bit more control, right? So we can stop router 1 in its tracks before it can generate any of those type 5 LSAs. We can stop in its tracks and go ahead and say, okay, this is not the set of type 5 LSAs that you'll be generating. You'll be generating this type 5 LSA instead. And that's where the power comes in. Because now we have control over what goes into that LSA. We're not breaking any rules of OSPF because the type 5 LSA would never be generated, right? So if we have those 8 prefixes, right, let's look at the area 0 LSDB here, right? If I go into text mode, right, without summarization, and if I redistributed all the connected route, say that redistribute connected subnet route map test. Hint, that is the command I will be using because I have a route map defined test that has a that matches an ACL that matches the loopback interface. But anyway, this is the command I will be using, right? Which will create, without summarization, without the summary adjust command, will create type 5 LSAs for 50.0.0.0/32, 50.0.0.1/32, and going down. I hopefully don't have to complete this list. You get the point. 50.0.0.7/32. It will create type 5 LSAs for all of these interfaces, for all these prefixes rather. And when it gets advertised to router 2, right, router 2 will have the exact same set of type 5 LSAs, so we're not breaking any rules. Now, with redistribution, when we do the summary adjust command, we're stopping router 1 dead in its tracks. We're saying, okay, you know the LSAs that you were gonna generate? Well, how about you generate this one instead? How about you generate 50.0.0.0/27 or 29 rather, right? Because again, we want to keep our subnet mask as small as possible, right? So 50.0.0.0/29, that sounds good, right? And router 1's like, okay. And guess what gets advertised to router 2? List 1 type 5 LSA. We are not breaking any rules of OSPF here. They still have the same LSDB down to the checksum because we stopped router 1 before it could generate any type 5 LSAs for the interfaces that we actually redistributed. We overrode its redistribution logic by using the summary adjust command in a sense, right? So that's the simplified version of what's going on here. So with this example, right, this is the final example that we're going to be doing. Let's say that I already have a route map defined here, right? Test that matches an ACL of 1. If I do show IP access list, we can see that standard IP access list 10 permit 50.0.0.0 and then wildcard bits 0.0.0.7, which is the wildcard mask of the subnet mask 255.255.255.248, aka /29, which should match on all of our interfaces here. What I'm going to do is I'm going to go to an int range LO0 to 7, and we're going to go ahead and do a no IP OSPF 1 area 0, just to go ahead and take those interfaces out of OSPF. Cool, so now we only have list interface, the interface leading to R2, as our only OSPF enabled interface on the router. So now we can redistribute, right? So if I go into the router OSPF process, we're going to say redistribute connected. Those are connected routes. And we're going to go ahead and say subnets, just for good practice. And then we're going to say route map test, which is the route map name. I'm just doing, you don't have to do this. This would work without that parameter. I'm just doing this so it doesn't accidentally redistribute any other connected routes in, just for cleanliness sake. So redistribute connected subnets route map test. So now if I go to router 2 and I exit router configuration mode and I look at show IP route OSPF, this should be OE2. Yep, so we have 50.0.0.0 to 0.0.7 as O external type 2 routes. Now, here is the command, summary address 10 or 50.0.0.0, and then we have to provide our summary mask, right? 255.255.255.248. So now, again, we get our conflicting LSA ID, that's nothing to worry about. If I go back over here to R2, we can see we've summarized our E2 routes, right? If I go to our show IP OSPF database, we can see here our type 5 AS external link states, and this is not tied to a particular area, right, is 50.0.0.0. If I do a show IP OSPF database external, you can see that this is our network mask /29, right? If I go into here, right, show IP OSPF database, we can see we have our type 5 AS external link states. So remember that the type 5 LSAs are not tied to any particular area. These loopback interfaces are never being put into the form of type 1 LSAs. They're being put into the form of type 5 LSAs. And that's, again, where we get into the power of being able to modify our type 5 LSA generation on the fly. But yeah, that demonstration, the quick little demonstration of type 5 LSA based summarization, we'll go ahead and wrap up this particular video on our CCNP route summarization concepts. Today we covered LSPF route summarization, both inter-area, and I do a bone at you with the external summarization at the end. If you want to see the other two videos that are coming up, so there's one coming up on BGP, there's another one on EIGRP, and then there's some other videos such as why that no zero route exists. Go ahead and hit that subscribe button, hit that like button, hit the notification bell, and leave a comment in the comment section below if you have any other questions or thoughts about the video. I really appreciate you guys' feedback, and I love your answering your questions. I love doing this, so if you could go ahead and hit me with some feedback, I'd really appreciate it. But yeah, I hope to see you guys in the next videos, and yeah, have fun and more Cisco. Yeet! Oh, and just one more thing before I forget to mention it. If you want to check out the configurations for this lab, go ahead and hop over to my GitHub. The link is in the description below. I'm going to link to the specific folder where it is. I'm going to copy all the configurations for both the, I'm going to have the inter-area summarization in there as well, just for a more complete set, but I'll have both the external summarization commands and the inter-area summarization commands in a configuration file in that GitHub, just in case you want to see it. So again, if you want to go ahead and replicate this lab or examine my configurations, go ahead and check the link out in the description below to my GitHub. Anyway, with that, the video is actually over, so have fun, guys. Bye for now.